Hello everyone, welcome to lecture number 4 of engineering mechanics. In previous lecture we have learned about the scalars and vector quantities, components of a vector and some operations on vectors. In today's lecture we are going to learn about moment of a force, couple and couple moment and transfer of a force to a parallel position. So let's start with the moment of a force. The tendency of the force to rotate a body is called moment. So, whenever there is a body and we applied force in some direction, for example in this direction, and it will rotate the body about a point, about any point, let us say this point. If it tries to rotate the body about this point, then this force creating a moment on this body which helps to rotate this body about a particular point. The moment of a force about a point is equal to the product of the force and the perpendicular distance of the point from the line of action of the force. If this is the point about which a body is to be rotated, and this is the line of action of the force, and this line of action of force is separated by this point with a distance d, then mathematically the moment of this force about this point O will be given by F into d, which is force into d, and this d is the perpendicular distance between the line of action of force and the point O. For example, let us see in this figure we applied a force on a wrench to loosen this nut. Basically what we are doing here is we are creating a moment about this point O. Let us say this point O. We are just creating a moment about this point O which helps to rotate this nut and finally helps it to loosen from this point or open this nut. Similarly, on the other hand, if we see an example of a door which is hinged at this end, when we apply a force B in this direction, the door will start rotating about this hinge. So basically in both this figure or in both this example, we are just creating a moment which helps the body to rotate in the particular direction, and the direction of rotation of the body will depend upon the direction of the force applied. Unit of moment is Newton meter. As we already know that moment is equal to force into distance. The unit of force will be Newton and the unit of distance will be meter. So the unit of moment will be Newton meter. Sign conventions. Whenever a force tries to rotate the body in clockwise direction, then it will create a clockwise moment which is taken as positive. And whenever a force is applied in the direction which tries to rotate the body in anti-clockwise direction, then it will create anti-clockwise moment and it will taken as negative. Next is couple. A system of two equal parallel forces acting in opposite direction separated by a distance form a couple. So let us say these are two forces F which are parallel to each other but are acting in opposite direction, separated by a distance. Let us say this distance is d. So this similar forces which are equal in magnitude but opposite in direction will try to rotate the body about this point O. So again, the two forces are trying to rotate the body, which means that they are creating a movement, but about this point. So the rotational tendency of the couple is called moment of the couple and is given by F into D, which is similar to the formula of moment because they are creating a movement. Unit will be same, Newton meter. Now let's understand the example of couple. The rotation of a steering wheel. When we rotate a steering wheel, we have to apply the force in these direction which are equal in magnitude but opposite in direction, separated by a distance. So this arrangement form a couple. Also, when we loosen or tighten a screw, we use a screwdriver and we rotate the screwdriver to tighten or loosen the screw, and we are applying the forces on the head of the screw. This is the head of the screw in this direction. So we are applying the two forces, one in direction and one in this direction. These two forces must be equal and separated by a distance d. So this arrangement is also form a couple. Now the sign conventions of couple. When a couple tries to rotate the body in clockwise direction, it will called clockwise couple and it will be taken as positive. Similarly, when a couple rotates the body in anti-clockwise direction, then it is termed as anti-clockwise couple and it is taken as negative. So these are the sign conventions which we are going to use in the numericals. Now, transfer of a force to a parallel position. Consider a force P acting on a body at a point A. So this is the body and this is the point A where the force is acting in this direction. We have to now transfer this force to this direction, now on this point in the same direction which is parallel to the previous line of action of force. So in order to transfer this force from point A to point B, let us take two forces of the magnitude P, which is equal to this one, our force which is to be transferred, but in opposite direction. So the net effect of these two forces at this point will get cancelled out. So as we see, then when we applied the force like this on point B, then let's see that this arrangement is form a couple, and this can be represented by this point. So what we do is the point B, and we represent this arrangement or this couple, or we are taking the moment of this couple about point B, and it will like this. So this is the moment of this couple about point B, and will be given by, what is the formula? P into D. P is the magnitude of the force and D is the distance between the two forces. So finally what we get, in order to transfer this force from point A to point B. Now we get a force in this direction which is parallel to the force applied on the point A, and additionally to that we also get a moment of a couple which is equal to P into D, right, force into the perpendicular distance. So whenever we transfer a force to a parallel position, then we will get a force in the same direction which is parallel to the previous one, and additionally we have a couple also at the same point. So in this manner a force can be transferred to any parallel position. So that's now for today's lecture. Happy learning.